An angle consists of two rays or half lines that originate at a common point called the vertex. These two rays, so for example, if I were to talk about my unit circle again, and I drew, I'm going to start here at what I'll call the origin, and that's a ray. And you can even say where I started from was a ray. There's my two rays. Okay, they started a common vertex. They have names. This is the initial side, and this is the terminal side, because I'm saying I'm going that direction. So I'm starting at 0 and I'm going to whatever that angle is. We usually refer to angles as lowercase Greek letters. Most often I'm going to use theta. This is theta. Alpha, beta, theta, gamma. And we always call this 0 degrees. Again, if I'm going counterclockwise from my initial side, I'm going in the positive direction. And if I go the opposite direction, clockwise, I'm going in the negative direction. Let's say I want positive 45 degrees, I would go here. If I want negative 45 degrees, I'm going to go here. Let's start talking about the actual unit circle. A circle whose center is at the origin and whose radius has the length of 1, which is what we already said. That's why we call it a unit circle. And we always have this equation, x squared plus y squared equals 1, honestly, because anywhere I put a triangle, I can say this is x, this is y. Using the Pythagorean theorem, x squared plus y squared has got to always equal 1 because the radius of this is always 1. What if I want to know what this point is? Well, let's say we're just on an XY coordinate system, and I want this point right here. We know the radius is 1. So here, the x value has to be 1, and the y value has to be 0. And if I go over to this side over here, well, the x value here is -1, and the y value is 0. And again, if I go up to the top point here, I can say, well, here x is 0, y is 1, and at the bottom point here, x is 0 and y is -1. So that gives me 4 points right away on my circle, and I can use this equation. I can see that it works. 0 squared plus 1 squared equals 1. We've already talked about 45 degrees. So if I go here, I know that this length in the x direction is the square root of 2 over 2. And it matches exactly the length in the y direction, which is the square root of 2 over 2. So if I want to know what the x and y coordinates are, it's the square root of 2. They're both the same because 45 degrees, remember the sides are always the same. Now, here's where it gets more interesting. So let's say I take this triangle, and it was here. This was 45 degrees. We know that that point on the xy axis is the square root of 2 over 2, comma, the square root of 2 over 2. And that refers to the length of each side on this triangle. If I take that triangle and I flip it over the y-axis, don't I get a triangle that looks like this, where this right here is still 45 degrees. And they're the same triangle, the length of the sides have to be the same. The only thing really different here is in quadrant 2, the x values are going to be negative. So this is going to be negative the square root of 2 over 2. but the y value is the same because it's still positive in quadrant 2. So it'd be positive the square root of 2 over 2. And then I could take this same triangle. Let's just draw it in right here. That was 45 degrees. And now what I'm doing is I'm flipping it down into quadrant 3. Where this is still 45 degrees, the side lengths have to be the same. So I know my values. The only thing different in quadrant 3 would be they're both negative x and y. So this would be negative the square root of 2 over 2, negative the square root of 2 over 2. Once I know the values in my first quadrant, it makes it a lot easier to find the values in every quadrant because the triangles are the same. I can now take that same triangle and flip it over here into quadrant 4. So if I put it in this quadrant, I'm still saying that's 45 degrees. And this point here, well, now the x value is positive and the y value is negative. Here's the entire unit circle with all the points basically that we would memorize. Of course, again, I'm going to say, please don't memorize all this. This is all in degrees. Do not memorize it. I wanted to show you what points we're using. Notice we're using 30 degrees, 60 degrees, which is the same triangle. I already showed you that back here, that 30 degrees and 60 degrees, it depends on how I draw it, right? I could draw it like this. And then now this is 60 and this is 30. It doesn't change the length of the sides.